Well, hello everybody. What I need to do with you today is I need to cover section 3-2. 3-2 has two different parts in it. Part 1, we're going to look at and review how to graph the step functions. The reason they're called step functions, guys, is when we graph them, they will look like this. And we'll talk about where the open dot and closed dot is, but that's what the step function will look like. And then we're going to switch gears, create a note card, and then I'm going to give you some information about circles. Two items that I believe you touched on last year in Advanced Algebra 2, but we'll refresh your memory and make sure that you're good. The things that you're going to need today, you need to have that class example sheet in front of you to follow along with. Your calculator really won't be a big deal today. A lot of this we'll do in our heads. You will need a note card. If you don't have a note card, write the information about circles on a piece of paper. We'll give you a note card and we'll transfer that over. So, where I need to go with you today is right here. I need to talk about round up and round down functions. Well, if you see a symbol that looks like this, guys, that means round down to the next integer. So for instance, if I had 5.4, you would round that down to 5. Sometimes it is also written like a double parenthesis, a double bracket. In FST, we try to use that symbol a little bit more, but every now and then the other would show up. And then we're also going to talk about the round up function. This was really popular back in the postage days and the cell phone days. If you were to talk 20.1 minutes, they would round up and bill you for 21 minutes. So kind of why they called it the cell phone function. Now, if you would, come over to your class examples there, where it's the 1 through 9. Now what I did, guys, is I placed a number line on this also. Whenever it's a round down function, you need to look to the left of where the number would be and give me that integer. If it's a round up function, of course you'd look to the right. Later on when we start graphing it, if it's a round down, you will have a closed dot on the left and an open dot on the right, because you want to include the left-hand number. If it's a round up, you will have an open dot on the left and a closed dot on the right. But I'll get to that when we graph here in a little bit. So just to click through this, here's number 1. That's the round down, so I would like to round down 3.9. So 3.9 would be right in here on the number line. I want to round that down to the lesser integer. Well, that would be 3. When I look at negative 3.9, it would be sitting about right there. Round that down, so round that to the left, I would get negative 4. 16 is already an integer, so it stays as itself. Now, notice we switched symbols here. So now on this one, we would like to round up. So think about where 3.2 would be on a number line. Round it up to the next integer and get 4. The negative numbers you got to be careful with. Negative 3.9 would fall right in here. If you round that up, though, it would round to negative 3. So really, guys, you just got to watch your round up or round down symbol. 7/8 would round up to 1. Now, the round up and round down functions, they are a grouping symbol. You have to simplify within your grouping symbols first. So I've got the round down of 2 times pi, which would be about 6.28. Round that down to 6. The round down of negative square root of 7 would be negative 2 point something. Notice I didn't stress on what it was. Rounded down, I'm going to get negative 3. Here I've got a round up function. I would need to simplify that first. If I add all those up, I get 205.1. Round it up, you got it, 206. So notice that those were all integers, as my pen messes up just a little bit. Okay? Now, before I start graphing on some of these, this one is not on your note sheet, but I'm going to point out some important things here and then tie them into the rest of the graphs. If you can decide on what this length is, I can show you a lot of shortcuts on graphing step functions. So picture this. This is the round down function, or it could be written as the double bracket of x. The current stair length or width of each step, its standard is 1. It changes only when there's a number in front of the x. So when I go to graph this, it's going to look like this. Since my stair length is 1 and it's a round down, I would like to include the left but not include the right. So this is going to look odd for a second, but there's going to be an interval of numbers that share the same y value. So I'm going to start with 0 and go all the way up to 1, but I'm not going to include 1 because that's my stair length. My next length would be bracket 1 to 2. Let's include 1 but not include 2. My next one, let's include 2 but not include 3. Now picture this. If I plug in 0 and round it down, I get 0. So remember we just said 0 for a second. Now let's come up to something really, really close to 1. 0.99. If I take 0.99 and round it down, I'm still going to get 0. Now let's go to the next one. Let's plug in 1. When I take 1 and round it down, I'm going to get 1. Let's go find a number close to 2. 1.99. Well, 1.99 rounded down is still 1. 2, when I round down 2 is 2. Let's come up to a number close to 3. 2.99. 2.99 rounded down is still 2. Here's a shortcut for you. If you plug in your bracketed number, that will be your y value. It'll take care of that whole interval. So guys, our step function is going to look like this. I'm going to plot the point. I'm going to have a closed dot at 0, 0. Here's where I got that closed dot. 0, 0. And then I'm going to have an open dot at 1, 0, right here. So I've got a closed dot at 0, 0. I've got an open dot at 0, 1. So there's my first step. Let's go get our next step. I have a closed dot at 1, 1, right here. I have a open dot at 2, 1. So I've got a closed dot at 1, 1, and open dot at 2, 1. I'm assuming my scale is counting by ones. Do it again. I've got a closed dot at 2, 2. I've got an open dot at 3, 2. So closed dot, open dot. Okay. Now, there's enough to continue your pattern. I'm not going to fill my chart out anymore, but I already know closed dot, open dot, closed dot, open dot. Let's run it the other way. Open dot, closed dot. So it's going to look something like, and when we graph these, what we'll do is normally fill the grid. There'll be times that's a hassle, and there'll be times that's okay. So guys, that's the step function so far. We'll come over to yours. Oh, I want to point something out just to speed things up. This is a computer-generated program. I want you to notice that the length of each step is 1 unit. From here to here is 1 unit. From here to here is 1 unit. From here to here is 1 unit. That's our standard length, is 1 unit. Now, I've also did this to speed things up. Here's the graph of y equal the round down of 2x. Notice that each length notice that this is 2, so this must be 1. This must be 0.5 and 1.5. Notice that the width of each stair now is only a half. Guys, I'm going to give you a shortcut here. To figure out the width of your step, there's two ways. Look at the number right here and give me the reciprocal of it. The reciprocal of 2 is 1/2. That tells me the length of each stair. Another way is take 1 over whatever's in front of there. So two ways. Peek at this one before I get to your class examples. Notice that when I put a 1/2 out front, notice that my length of each stair was 2. That's really important. So two ways to get that again. Give me the reciprocal, or give me 1 over 1/2. If you run that through your brain, you're going to get 2. If you can look at it and know the stair length, the rest is going to be easy. So, come over to your number 10, which says y equal to the round down of x. I could talk about the blue note card in this. This is going to vertically stretch it by 2. But here's how I'd like for you to attack it. We're going to create an XY chart. I need you to look at it and decide what the length of each stair is. There's no number directly in front of the x, so it's going to be 1. The 2's on the outside, so that doesn't affect the width or the length of the stair. It's also a round down. On a round down, you want to include the left end. So my interval is going to look like this. 1, well, let's use 0 first. It's going to look like 0 to 1. My next interval is going to be 1 to 2. And I have no idea why my pen does that. Notice I put a bracket on the left, a parenthesis on the right. My next interval is going to be bracket 2 to 3. Now guys, I'm going to talk you through this one a little bit, then we're going to shortcut it. I'm going to plug in 0. The round down of 0 is 0. Times 2 is still 0. Now, go close to 1. If I plug in 0.9, 0.9 rounded down is 0, times 2 is 0. Here comes a shortcut. If you will plug in the bracketed number, it'll tell you what every number in that interval will be. So I'm only going to plug in the bracketed number from here on out. Speed things up. For my next interval, I'm going to plug in 1. 1 rounded down is 1, times 2 is 2. 2 rounded down is 2, times 2 is 4. Now, let's go, when I graph these, I'm going to have, let's pick on this guy first, I'm going to have a closed dot at 0, 0. I'm going to have an open dot at 1, 0. How did I get that? I matched those up and those up. So closed dot at 0, 0. Open dot at 1, 0. So there's stair number 1. Let's go get this one. I'm going to have a closed dot at 1, 2, and an open dot at 2, 2. So 1, 2, closed dot, 2, 2, open dot. I want you to notice something. Notice I skipped the 1. That's what this vertical stretch does. It turns a 0 into a 0, a 1 into a 2, a 2 into a 4. So now let's go get the next one. I'm going to have a closed dot at 2, 4, an open dot at 3, 4. Now, instead of filling out my chart some more, let's run the table. The next one I'm going to have an open dot right here and a closed dot right there. I'm going to have an open dot right there oops, not there, down here, and a closed dot right there. That's open. Okay? So guys, the key thing, get your interval, plug in the bracketed number, and then we're going to be good. Here comes your number 11. Notice that there's a 2 in front of the x. So let's figure out the length of each square. Two ways. It's the reciprocal of what you see, or it's 1 over what you see. That's really important. When I set up my chart now, my interval is going to be in halves. It's still a round down, so I want my bracket on the left. So it's going to look like this. I'm going to go 0 to 1/2. I'm going to go 1/2 to 1. And I'm going to go bracket 1 to 1.5, which I'm going to call 3/2. 1.5 or 3/2. The fast way to get your y values, plug in the bracketed number. 2 times 0 is 0. 0 rounded down is 0. Plug in 1/2. 2 times 1/2 is 1. 1 rounded down is 1. Plug in 1. 2 times 1 is 2. Rounded down is 2. There's no number out front, so there's not going to be a vertical stretch. So I'm going to see something on y equal 1, y equal 2, y equal 3. So here goes. I'm going to have a closed dot at 0, 0, because that's my bracket, and open dot at 1/2, 0. So notice that my step length is only 1/2. I'm going to have a closed dot at 1/2, 1, and an open dot at 1, 1. At 1, 2, I've got a closed dot and an open dot. At 3, closed dot and an open dot. What a hassle this one is, guys, to fill our grid. Now let's run the pattern down here. I must have an open dot there and a closed dot there. Open and closed. Open and closed. Open and closed. And my pen helps me out there. Okay. So, the bigger the number, the more stairs you're going to have. So be happy when we see something like number 12. And if I get too fast on the video, just backtrack and hit pause. The length of each stair in this case is 2 ways. The reciprocal of 1/2, which is 2, or 1 over your b value. Once again, it's a round down function. So my bracket's going to be on the left. My step length is going to be 2. So I'm going to go 0 to 2. The 2 gets a parenthesis. Then I'm going to go bracket 2 to 4. Then I'm going to go, oh, excuse me, I'm going to go 4 to 6. To get your y values, plug in your bracketed number. So 1/2 of 0 is 0, plus 2 is 2. Go down to the next one. 1/2 of 2 is 3. 1 plus 2 is 3. 1/2 of 4 is 2, plus 2 is 4. Now, since there's no number out front, there's not going to be a vertical stretch. So you should see a 2, a 3, a 4, a 5, a 1, a 2, you should see all those. The graph of it, closed dot at 0, 2, open dot at 2, 2, and a stair length of 2. On the interval 2 to 4, I've got a closed dot at 2, 3, an open dot at 4, 3, I've got a closed dot at 4, 6. That's not going to fit. Now let's run the pattern the other way. That means at y equal 1, there's going to be an open dot there. 2 units away is a closed dot. At 0, there's going to be an open dot there and a closed dot there, and then we got it. Okay, so guys, those were 3 round down functions. Look at your number 13. Notice that's a round up. That's a round up. There's no number in front of the x, so my stair length is going to be 1. But since it's a round up, we want to include the right side. So when I go to fill out my intervals, I'm going to go from 0 to 1. But 1 gets the bracket. The right side gets the bracket. When I go to my next one, I'm going to go 1 to 2. 2 gets the bracket. My next one, I'm going to go 2 to 3, but 3 gets the bracket. Plug in your bracketed number, and we would get 1, 2, and 3. Guys, the only difference between this and the other graphs, this one's going to have the closed dots on the right. So I'm not going to graph them all since it's a video, but I would have an open dot at 0, 1. I would have a closed dot at 1, 1. So there's that. On my next one, I'd have an open dot at 1, 2, a closed dot at 2, 2. Okay? And then we'd do rest them up, rest them down. But the big thing I wanted to show you there is the dots switch. The round up is on the right. Okay? So guys, that's part 1 of the video. That's part 1 of the video, our graphing or step functions. Now, I'm going to totally switch gears. And I'm going to take you to the world of circles. Now, what you will need to do at some moment is you'll need to pause the video and write this information on a note card, because it's really important. And then, like I said, if you do not have a note card, go ahead and write it on a piece of paper. Ask Miss Dinahan or myself or your teacher for a note card, and we'll get that on there. But where I'm going to take you now is to the world of circles. The general form of a circle is x squared plus y squared equal r squared. That would have a center at 0, 0 and a radius of r. So guys, here's what this means. If I was to give you x squared plus y squared equal 9, it would look like this. The radius would be 3, so I'd have 3, 0, 0, 3, negative 3, 0, 0, negative 3, and that would be my circle. Now, of course, I could move that circle around. Notice that the circle has 2 grouping symbols. 2 grouping symbols. So the center would be at HK. The radius would be of R. It's going to be a lot simpler here in a second when I flip the page and you see numbers. Right now, when it's in terms of H and K, it's confusing. Now, also, guys, you will need on your note card 2 very important formulas that show up when we deal with circles. You'll need the midpoint formula from your Algebra 1 days or your Geometry days. You will also need the distance formula. So like I said, pause the video, write those down, because we're going to use them. Otherwise, I'm moving on. So here's your number 14. I'm going to give you x squared plus y squared equal 9. There's no grouping symbols in here. There's no grouping symbols. The center is going to be at 0, 0. The radius is going to be the square root of 9, which is 3. A little bit easier with numbers. Look at your number 15. I've got 2 sets of grouping symbols. So my center is going to go 2 units to the left, opposite of what you think since it's inside the grouping symbol, and 5 up. The radius will be the square root of 16, which happens to be 4. On to number 16. The center of this thing will be 4 units to the right, down 3. My radius is going to be the square root of 80. But we're going to leave that exact. You don't get to type it into your calculator and tell me it's 8 point something. I'm going to think of the square root of 80 as the square root of 16 times the square root of 5, which is 4 radical 5. That's the exact radius of that circle. Number 17, my center is going to be at negative 3.2, comma. Notice that there's no grouping symbol with the y, so it doesn't get translated up or down any. My radius, once again, square root of 40, which I'm going to think of as square root of 4, square root of 10, which is 2 radical 10. Okay. So look those over as you need, but guys, grouping symbol, opposite of what you think. Now, on the next little group, we're going to give you the center and the radius and ask you to give us the equation of the circle. So we're going to go backwards of 14, 15, 16, and 17. So here goes. Number 18, for the center to be at 1, 4, inside the x, I must see a x minus 1 quantity squared plus y minus 4 quantity squared equal the radius squared, so 9. Here goes my number 19. For my center to be at negative 3, 7, I've got x plus 3 quantity squared plus y minus 7 quantity squared equals 16. My number 20, there's no movement left or right, so I've got x squared plus y squared equal, I need 3 radical 5 squared. To do that, 3 squared is 9. Square root of 5 times square root of 5 is 5, so this becomes 45. And on my 21, fractions, no big deal, guys. This becomes x plus 2/7 squared plus y minus 3/5 quantity squared equal 16 over 121. So there's where we are so far. And guys, that leaves me about 4 equations to kind of talk to you about. 2 of them being really, really easy. 2 of them taking just a little bit of work. So, here goes our number 22. We would like to write the equation of a circle that has a center at 3, negative 7 and passes through the point 1, 5. Now, you do not have to draw a picture on this, but I'm going to draw one just to kind of show you what we're finding. Right now, my center is at 3, negative 7. And we're going to go through the point over 1, up 5. So here's my center. There's a point on the circle. I'm going to have a circle that looks something like that. I'm going to have a circle that looks something like that. This right here would represent my radius. So now here goes. On my number 22, I know my center is at 3, negative 7, so I know partial answer is going to be x minus 3 quantity squared plus y plus 7 quantity squared equal. Now I got to go get that radius and square it. Here's where that distance formula on your note card comes in handy. The distance from the center of my circle to a point on the circle can be found by the difference of your x's squared plus the difference of your y's squared. So 3 minus 1 is 2. 2 squared is 4. The difference of the y's is 5 minus negative 7, which becomes 12. 12 squared is 144. Now when I simplify this, I get the square root of 148. The radius then is the square root of 148. You got to square that, and that's what goes here. Now notice, guys, I didn't reduce that like I did the other ones. Since I'm putting it in the equation, I'm going to square that and just get 148. So there's the equation of a circle with the center at 3, negative 7, passing through the point 1, 5. I sketched a picture to kind of see what I was going with. Here's number 3. Number 3 is a little bit easier than that one, to be truthful. My center is at 3, 5. So if I just show you a quick picture, there's my center, over 3, up 5. And I would like to be tangent to the x-axis. Remember from your geometry days, tangent means touch the x in one place. So my circle might look something like that. Now, my equation is going to look like this so far. X minus 3 quantity squared plus y minus 5 quantity squared equal. Now, I need the distance from here to the x-axis. I need the distance from there to the x-axis. Now notice that's vertical distance. So to get to my y-axis, I need a 5. So that distance is 5. Squared is 25. So there's the equation of my circle with the center at 3, 5 that's tangent to the x-axis. Here comes my next to the last one. Just to draw you a picture, the center is at negative 7, 6. Negative 7, 6. And we're going to be tangent to the y-axis. So, we're going to have something that might look like that. Well, you already got part of your answer since you know the center. I'm going to have x plus 7 squared plus y minus 6 squared equal. Now, I've got to get the radius. So I need to figure out how far it is from there to there. Since that's parallel to the x-axis, it looks like it's going to have a distance of 7. Squared is 49. So there's the equation there. Okay, I got just a little snafu there, but let me hit that and start that. So now we're ready for our last one. Picture what we're looking for on this last one. It says 6, 4 and negative 4, 10 are the endpoints of a diameter. Well, if you look at the numbers, I'm over 6, up 4. There's the ordered pair 6, 4. Here's the ordered pair negative 4, negative 10. Guys, this here is a diameter. The circle you're trying to find would look something like that. Would look something like that. Now, notice on your note card, we have not used the midpoint formula. Here it goes. Since these are endpoints of a diameter, it must pass through the center. I need to figure out the midpoint. So step number 1, let's go get the midpoint, which is really the center of the circle. Now, to get your center, you add up the x's, divide by 2, add up the y's, divide by 2. So 6 plus negative 4 is 2, divided by 2 is 1. 4 plus negative 10 is negative 6, divided by 2 is negative 3. So there's the center of my circle. My center is at 1, negative 3. Now, I've got the center. Now I need the radius. Two ways to get the radius: the long way and the better way. The long way would be find this distance, reduce it, divide it by 2, and square it. You'd have to divide it by 2 because it's the diameter. But guys, since we want the radius, let's go from the center to one of our endpoints. It does not matter which one. So now let's use the distance formula. I'm going to go the difference of the x's squared. So 6 minus 1 is 5. Squared is 25. Plus 4 minus negative 3, or negative 3 minus 4, which is going to be 7. Squared is 49. Add those up, you're going to get the square root of 74. Now, your final answer? My center is at 1, negative 3, x minus 1 squared, plus y plus 3 squared, equal 74. I squared the square root of 74 and got the answer. Okay? Now guys, assignment-wise, you should have a worksheet. There's nothing out of OneNote. No OneNote on this one. Everything's on your sheet there. The first side is just graphing the step functions. The rest of it should kind of flow for you. Good luck. Come in if you need any help.